Alright, so in this example problem we have a wire that has a diameter of 2.35 millimeters and a particle density of 7 times 10 to the 28 meters to the minus 3, so per meter cubed. A charge at 450 coulomb flows through the cross-sectional area of the wire every 60 minutes. What is the current through the wire, and what is the drift velocity of the charge through the wire? Alright, since we're given the relationship where we have 450 coulombs flowing through the cross-sectional area of the wire every 60 minutes. Our dq is 450 coulombs, and our dt is 1 hour, so 60 minutes, converted into seconds, which is 3,600 seconds. So since current is dq divided by dt, we can say that the current is 450 coulombs divided by 3,600 seconds, or 0.125 amps. In our second part, we want to know what the drift velocity is. So now that we know what the current is, we can use our relationship of current in terms of drift velocity in order to calculate this. So I have the current, which is the 0.125 amps, times the particle density, which is 7 times 10 to the 28 particles per meter cubed, which I've then taken times the charge of an electron, so the absolute value of it, 1.6 times 10 to the minus 19 coulombs. The drift velocities are unknown, and then the cross-sectional area. So the cross-sectional area of a circle is 4 pi r squared, but since I gave it a diameter, we had to take half of that. So rather than taking half of it and then plug it in, I plugged in the relationship for area where you plug in diameter. So it's divided by 2, but that 2 is squared, so you have that 4 that pops out up front. So that's why there's a 4 here. So I plugged in our 2.35 times 10 to the minus 3, go to convert those millimeters into meters, and then we're squaring that. So we end up with a drift velocity of 2.57 times 10 to the minus 6 meters per second. And so you'll notice drift velocities are relatively slow.